Alright, we are going to talk about Niels Bohr today, but I forgot one thing. I did not take a look at Rutherford's model, what he said an atom actually looks like. Many times this is also called the planetary model. It is small nucleus with electrons orbiting at a great distance is what his model of an atom is. Okay, now I would say that that model has been shamelessly ripped off by NASA, but my students tell me it's been shamelessly ripped off by Jimmy Neutron, which this is actually the model of an atom that we are probably most used to seeing. And it's got good parts about it, but it does have some bad parts about it as well. It does have some things that are actually not true. Okay, now next guy to come along, Niels Bohr. Okay, he came along, he added something to the atomic theory. He added quantum energy levels. Okay, now if you're talking about classical physics, stuff like that, if we have the Rutherford model, those electrons are moving. Those electrons would give off energy just because they're moving, and that would give them less and less energy, so they would slow down, they would come into the nucleus, and they'd crash into the nucleus, and that would be bad. Well, Niels Bohr, he gave us quantum energy levels. Basically, he said we have the nucleus and we have these electrons, but these electrons can only follow specific orbitals around the nucleus. Okay, it could be on that orbital, or an electron could be on this orbital, but every atom has its own orbital size, and the electrons can only be found on the orbitals. They can't be found in between, they have to be found on the orbitals. So he called them quantum energy levels. What's a quantum energy level? It's a fixed path. It's a standard path. And these paths are going to be different for different atoms. Some atoms it's going to be really, really close together. Some atoms it's going to be further apart. And that is how atoms can make pretty colors. A lot of times we call this the flame test. We watched a video in class. I'm not going to show it right now, but we watched a video and then we burned a few different kinds of atoms like cobalt and boron and copper and stuff like that, and we see that these atoms, when they're excited, when they're given energy, that they glow, that they make different colors, such as copper makes a wonderful green color, stuff like that. Now we want to explore how atoms make these different pretty colors. Easiest way to do it is actually just by drawing it. Okay, so I'm going to have an atom over here, nucleus is positively charged, it has an orbital, and I'm going to give it another orbital fairly close by. I'm going to put an electron on this orbital. Now we're going to go ahead, we're going to give energy to that electron. That electron's going to jump up an orbital. It's going to get excited, it's going to go to higher energy level. But the issue is, as soon as it gets up there, what goes up must come down. That electron, shoom, it's going to come back down. Well, if it absorbed energy to go up in energy level, it has to release energy to go down an energy level. Okay, now let's take a look at different energies. This right here is the electromagnetic spectrum. We're going to cover it in more detail later on, but we can only see the middle of the electromagnetic spectrum. Way down here we can use it, those are like radio waves, stuff like that. We can use them, but we can't see them. Up here we have gamma radiation. Once again, we can use it to cure cancer, but we can't see them. This is the visible spectrum right here of the electromagnetic spectrum. Down here you have red. Up here you have, I call it blue a lot of times. It's actually violet is the top, but I call it blue just because more kids have blue shirts and stuff like that. So now this right here, we talked about how this electron just got a little bit of energy to pop up an energy level, and so it released a little bit of energy when it came out. You could also say a lower frequency is released when it comes back out. Well, what does our eye see that as? Our eye actually sees that as red light. So some things like strontium, they make red flames because of the size of their atoms, because of how far apart those orbitals are. And that's all the time I have right now. Tune in.